मैम का नेटवर्क इशू है, वो 2 मिनट में ज्वाइन कर लेंगी।
ठीक है ठीक है।
Good morning. Sorry for the delay due to network issue. I could not able to join. So I'm going to share the screen. Is my screen visible to all of you?
Yes, ma'am.
Okay. So today I'm going to discuss the origination with open feed water heater. So that is also known as your direct contact type of feed water heater. So in case of direct contact type of feed water heater, there the mixing of the steam and feed water will achieved inside that heater, and that outlet of that heater will be in such a way, it is adjusted in such a way that the quality of the uh, steam or condensate will be the dry saturated. So first I have shown you the single stage heating process. So here the reheater is used single stage type. हेलो. हाँ राकेश. हाँ राकेश, मैं क्लास ले रही हूँ, बोलो. अच्छा ठीक है, आप. अच्छा ठीक है. हाँ. So there will be the boiler, and from the boiler outlet, if you are observing here, the outlet is 1 kg of steam. So it is circulating inside the turbine. So at the outlet of the turbine, we are getting the net work output. Here it is connected to the generator to get the electric power. So if you are observing in this case, it is a single stage type of heater. Single stage of type of heater means in mid of that extraction process, we are drawing some amount of steam to increase the temperature of the feed water heater. So here I have taken the M1 kg of the steam extracted from the turbine, so which is enter to the open feed water heater. Then it here at the outlet of the heater, that we are getting 1 kg of steam, which is again pumped to the boiler. So at the outlet of the turbine, so here it is a point 3. So in this case, your amount of rejection of the steam will be 1 minus M1, because in between of this we are extracting the M1 amount of steam. So a 1 kg of steam was circulated. So at the outlet, we will get the 1 minus M1 amount of condensate. So this one is a theoretical calculation and theoretical assumption we are taking. So all the process are in this case are reversible process, so ideal process. In practical case, there will be the losses you can consider. So M1 minus M1 amount of steam is entering to condensate. So this one is the condenser. So if you are observing in this case, here also I have mentioned 1 minus M1 kg. So through last class you have doubt in this case. So that one I'm going to clear it. So if it is the 1 minus M1 steam is entering to the condenser, so it is the ideal cycle. So that's what. So we are assuming that 1 minus M1 kg of condensate will be formed. Okay, so that condensate will pumped to the heater at the point 4. So that pumping process will be the isentropical pumping process. Okay, so this one is the pump 2. Use it here. So last class we have not included this connection, so that's why you were getting confusion. So this one is your pump where we are giving the compression work or pump work in work input. So it is the low pressure pump. So that 1 minus m1 kg of condensate will pumped to the feed water heater um, at the pressure of in this case the pressure will be the intermediate pressure. So let us take that is the P2 pressure, and here it is the P1 pressure. Okay, and in this case it is your P3 pressure. Got it? So that it will pump to the pressure P2 pressure. So if you are observing, this is the 1 to 2 will be achieved one expansion, and then we are having the 2 3 expansion. So here it is the here the mass is your 1 minus m1 kg. In this case, it will be the 1 kg. Okay, or it is the m1 kg. Okay, it is 1 kg, then we are getting extracting the m1 kg, where here it is the 1 minus m1 kg. Okay, so in this case the heat rejection will achieve at this point. So this one is the heat rejection. Okay, qr. So 3 to 4 is the condenser process where we are getting the heat rejection. Then 4 to 5 at this point we are pumping the condenser to the pressure P2 pressure. Okay, so this is the P2 pressure, this to this is the P2 pressure. So in this case, your mass will be the 1 minus m1 kg. We are considering that amount, whatever the steam is entering to the condenser, that amount of condensate is formed at this point. So 1 minus m1 kg we are considering, and we are pumping to the pressure of the low pressure feed water heater. So here in this case, there will be the exchange of heat due to the mixing process. So the here the condensate which is formed at the outlet is achieved in such a way that in this case, if you are observing it with a dry saturated liquid. So we are considering the here the mixing process and due to the heater will be, it will give you the dry saturated liquid. Okay, so then there will be the pumping process, that is the 6 to 7 process. So here high pressure pump will be used. If you are observing in this case, the pumping process is nothing but it is a reversible isentropical compression process. So that feed water will be pumped to the pressure P1. So it is the boiler pressure. So again at this case there will be the circulation of the 1 kg of the feed water heater to the boiler. Then that 1 kg of the feed water will again converted into the 1 kg of the steam. Okay, so like that the process will continue, and in this case I have used a single stage of heater. So for this one, we can write the steady flow energy equation, and we will find out what will be the efficiency of your boiler or steam power plant. Okay, so in this case, in case of the regeneration cycle, what will happen? The thermal efficiency will increase due to the reduction in the heat addition. And your in regeneration cycle, one drawback is that here in this case you will get the less work output. The turbine work output will be reduced. If you are considering here same amount of 1 kg of steam is flowing in the same case, then we will get the step work. So in later stage I will show you how this loss work we are considering. Okay, got my point? So here what we are going to see in this case, we have to find out what will be the thermal efficiency of the regeneration cycle. So advantage of the regeneration cycle is that here your mean temperature of the heat addition will reduce. Another thing is that it will this open feed water heater will work as the one type of de-aerator. So once I have told you the what is the function of the de-aerator, if you have remembered, so de-aerator. The function of the de-aerator means it will reduce the dissolved gas. right? So it will reduce the dissolved gas, means there may be the some other type of gases will be also present. So this open feed water will work like as a deaerator, so dissolved gas will be reduced. So because of that one, there may be the reduction in of the corrosive gas, and turbine blade will not corrode. Okay, so that is one function. So let we will find out what is the steady flow energy equation used in this case. So first one is your okay. So where we are applying at the case of the turbine. Okay, so here it is the 1 kg of the mass is used. Mm, okay, so if you are observing in this case, due to the use of the feed water heater, what will be the enthalpy at the outlet, and in this case inlet, that we are going to write down. So these two are inlet to the heater, and this one is the outlet. So let me write down that equation for the heater. So for the heater, this will be the M1 into H2. So in this case, the enthalpy will be the H2, and the mass drawn from the turbine will be the M1. So first, it is the M1 into H2 plus, again inlet we will consider, as I have already told you, the same amount of condensate will circulate, or feed water heater will be circulated in case of the 4 and 5. So that means we will have the 1 minus m1 kg of water is entered into the, or condensate is entered into the heater. Okay, so in this case 1 minus m1 into 5, 1 minus m1 into 5 means in that case enthalpy will be the H5, right? So which is equal to, the outlet is 1 into H6, 1 into H6, right? So from this equation we will, if you are again opening the bracket, then equation I can write down as M1 H5 is equal to H6. So which is in this case M1, I will take common. M1 is your H2 minus H5 is equal to your H6 minus H5, right? So in this case we will get the M1 will be how much? H6 minus H5 upon your H2 minus H5. Okay, so this will be the amount of steam drawn from the turbine, which is utilized in the feed water heater. So now I'm going to find out what will be the heat addition. So heat addition, let us take Q1. So Q1 will be, heat addition will be, in this case will be how much? In this case, if you are observing, that is the H1 minus H7, right? So what is that one? That is your H1 minus H7. So heat rejection, let us take, that is your Q2. So heat rejection will be at this point, right? Right. So here it will be the 1 minus M1 into H3 minus H4. 1 minus M1 H3 minus H4. Got my point? So this is the heat addition and this is the heat rejection. Now we can get what is the turbine. Also we can write the what is the turbine work. So turbine work I can write like this. So that is the 1 into H1 minus H2. So simply I can write it here. Please wait for a minute. Sorry for the disturbance. Today I'm getting a lot of disturbance. I don't know why this is not working. So let me rejoin again.
Class over. Everyone can leave now.
Thank you, ma'am.
Thank you, ma'am.
Thank you, Ritika.
भाई दीपू ज्वाइन किया है।
जो लास्ट में लीव किया, जो लास्ट में लीव किया।
बाय दीपू सर।
टेक करो इसको।
साहिल को रहने दे लास्ट तक क्या?